I have shared my screen. Do let me know if you can see that.
Yes, sir.
Okay, so today actually we are going to see arithmetic operation, and in arithmetic operation, we have addition, we have subtraction, we have multiplication, we have division, and out of these four, we are going to only see multiplication and division in here before midterm. So actually, two topics that we are going to cover out of this slide. Uh, and most importantly, we are going to learn about those two topics, how our computer actually performs all these operations, multiplication, divisions, with only addition. We all know, right? We all know about these things that our computer only perform addition operation, right? In binary.
Yes, sir.
Do you know? Okay, so today we are going to see that actually our computer perform this addition with addition, subtraction, even subtraction with addition, like 7 minus 6, they complete this with 7 plus minus 6, and they find this minus 6 using the two's complement. So they actually managed to do some things with the binary numbers, and then finally performs addition with addition, subtraction with addition, multiplication with addition, divisions with addition. So today we are going to see how they actually perform these multiplications in binary with only addition. First, we are going to see theoretically how actually multiplication is being done in binary. Then we are going to try to understand that theory, and we are going to see the solution there. After that, we are going to try to map that theoretical solution with this algorithm in here, where they are actually performing the multiplication algorithm with only addition. So our main focus is to understand multiplication in here. For multiplication in this slide, there are two algorithms given, and for a division only one. So in this chapter, we are going to see three different algorithms, two for multiplication, one for division. And in those three algorithms, we are going to try to map how actually from the real theoretical solution, they have converted that to only addition solution. That solution has only addition operation in binary. Okay, so we are going to see that. So first thing first, this is the algorithm or flowchart you can see in here, and this is the hardware diagram for it. Before we understand the hardware diagram and the algorithm in here, we have to know the theoretical solution of this multiplication. Okay, so I'm going to show you the theoretical solution in here. Can you see this word file? Please let me know. Somebody
Yes,
has to give me continuous response
yes, sir.
so that it is easier for me to conduct the lecture. Okay, so you can see the word file. Thank you. So this is Amen and this is Amr. Why this is Amen and Amr? Remember, to multiply two number, we need a multiplicand, we need a multiplier to produce the result, which is actually we say product. The result is product in here. Now, uh, the number which we are going to, which is going to be multiplied by some other number. That number which is going to be multiplied by some other number, that is multiplicand. And multiplier is the number that multiplies some other number. So if I say something like this, for example, multiply 8 by 9, multiply 8 by 9. So 8 is the number that is going to be multiplied by some other number. So 8 is multiplicand, and that number is going to multiply some other number, that is multiplier. So multiply 8 by 9 means 8 is multiplicand, 9 is multiplier. So in here, this 8 is multiplicand and this 9 is multiplier. Okay. So this is the theoretical solution we need to understand first. And if we understand the theoretical solution, the solution we are going to see in here, we are going to try to map it with the algorithm or flowchart they have given, so that you can understand that all these multiplications in here are actually being done by only addition operations. So now how binary multiplications are being done. This is multiplicand 8, this is multiplier 9. So we are going to denote multiplicand with mn and multiplier with mr. Okay. So you guys are hearing me loud and clear? Please respond.
Yes,
Yes,
sir.
sir.
Hello.
Yes, sir.
Okay. So you are hearing me properly. So we have to understand the theoretical explanation of this multiplication algorithm. Okay. We are going to try to understand this theoretical explanation. Now, how we actually multiply these two numbers? We actually tend to multiply this mn with the right sided or zero number bit of mr first. 1 into 1000, that is 1000 in here in the first row, right? Please respond.
Yes, sir.
You guys have to respond, otherwise it will be difficult for me. Okay, thank you. So this is 1 into 1000. This is 1000 here in the output in the first row. Then what we do? We used to multiply this mn with first bit of mr. Remember, this is zero number bit, this is one number bit, this is second bit, this is third bit of mr. Initially, we multiply mn with first bit, then second, then third, then fourth. So after multiplying this mn with the first bit of mr, this is the result we got in the first row, 1000. Now we are going to multiply this mn with the first bit, that is 0 of mr. Now to do that, we give a space of a column, right? Please respond.
Yes, sir.
Yes, sir.
After we give the space, we multiply this 0 with this mn. Then we get this 40, 0, 0, 0, 0, all zeros in here. After we get this in here, we actually go to next line after this line is done. And in the next line, we give two space of columns, right? Two space or two cross signs to make two space, right?
Yes, sir.
Okay. Then mn with this 0 again, and there is this four zeros, 0, 0, 0, 0. Then for the last time, we want to multiply this mn with the last or fourth bit of mr. To do that, we give three space, one, two, three space. Actually, these three space are given in the output section. Okay. Then we actually multiply this mn with this one, and we get 1000 as the output. And after that, what we do? After that, what we do? We add all these columns in here. So after that, everything is addition in theoretical explanation as well, right? We add all these columns, right? Please respond.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So we are not confused about the rest of the part after the multiplication. When we actually finish this multiplication part in here, after that, what we do to find the proper result, that is only addition operation. So that we understand our computer can perform, but how actually our computer perform these multiplications, that is being done in here. That we have to see how this is being done in here in the algorithm. Okay. Now, when we actually add these columns, we tend to assume this cross as zeros, right? Please respond. Because when
Yes,
we add, we assume this cross or spaces as zeros, right?
Yes, sir.
Now we are again going to see how these spaces we can manage in the algorithm. How can we manage these spaces in the algorithm? Okay, so we have to see that this is our mn. Remember, this is our mn 1000. Initially, the product register is 0, all zeros, 0, 0, 0, 0. Now, how we are going to get these spaces in here in this multiplication? Using the shift left on mn one time. Okay, using the shift left on mn one time. Okay, so how can we do this? We are going to see first what we do in the multiplication. 1 into 8, 1 into 100, that is 8. Result is 8. That is the first row in here, first row. And in the second row, the output is actually 0, 0, 0, 0, 0, not 4 zeros. Because of this space, actually we are getting 5 zeros in here. To make sure we get 5 zeros by multiplying this 0 with mn, before the multiplication, we have to shift left the mn one time. What is shift left?
Multiply by 2.
Shift
Shift
means
left towards the
adding a
right.
0 at the right. So we are going to add a 0 at the right. Shift left is adding a 0 at the right. Okay. One time shift left means 1 0 at the right. Two times shift left means 2 zeros at the right. Is it okay? Clear?
Yes, sir. Yes, sir.
Okay, so if we shift left this mn, which is this mn 1 0 0 0 one time, we are going to add a 0 at the right, and we are going to get this as our new mn. And then if we multiply this 5 bit mn1 and then 40 with 0, then we are going to get this 5 zeros in here as the output, right? 5 zeros. Please respond.
Yes, sir.
Then in the next iteration, when we want to multiply this mn with this 0, we are going to shift left mn once again to make a more space, another space. Like in the first line, there is one shift left, makes one space, two shift left makes. So we are going to shift left once again. Six zeros. Then we are going to shift left mn again, multiply that with 1 to get this 1 and 6 zeros. 1 and 6 zeros. So is it clear how we are actually managing the spaces in here? So in the algorithm, we'll be able to see we have to shift left the mn each time after the first iteration. In every iteration, we are going to shift left the mn one time. And why is that? Because we need to make that space. Okay. So is it clear that we have to shift left the mn one time
স্যার
after
এখানে
the
পি
first
এর ভ্যালু
iteration?
চারটা জিরো কিভাবে হলো? পি ইকুয়াল টু
Do not
চারটা জিরো, এটা কই
get
থেকে
yourself
আসলো?
confused with p now. We are going to talk
Okay,
about
sir.
that later. Do not worry about that. Okay. But is it clear to you how why it is shift left mn one time in every iteration after the first one?
Yes, sir.
Why we have to shift left mn? Okay. Thank you. Thank you. Remember, when we are going to start the multiplication algorithm in our processor, what do we get? Registers, right? Please respond.
Yes, sir.
In registers, we have to store these values mn, mr, and we have to take another register to store the product. So initially, all the registers are 0, but we are going to replace mn with 8, mr with 9 in that register. Still, initially, before all this calculation, the product register will remain 0, right? Please respond. The product register will remain 0, right? Please respond.
Yes, sir.
Okay, so the product register is initially 0. Now, before we go to the simulation to check the algorithm, we have to know if they can get these outputs like 1000, these zeros with only addition or not, because still we can see these are multiplications that our computer cannot perform, because our computer can perform only addition. Now we are going to see how this output can be achieved with only addition. Remember, the product is 0, p is 0, mn is 1000. If we do this calculation, p plus mn onto register p, what will happen? If we add these two numbers, p, this is mn, this is p. If we add these two numbers, we are going to get this number. And this number is similar to this number, right?
Yes, sir.
So can we say without multiplying, we can get that output with only addition?
Yes, sir.
Okay, so in the algorithm, we are going to see they have used this addition in here. Add multiplicand mn to product mn plus p and place the result back to product register. So mn plus p then store that result in p. So mn plus p onto p register. Is it clear? Mn plus p into p.
Yes, sir.
Is it
Yes,
clear?
sir.
Okay, so if this is clear, we are going to talk about the algorithm in here. Like I have said, we need a register to store mn, we need another register to store mr, and we need another register to store the product. We are going to see the hardware diagram in here. And you can see in the hardware diagram, they have this multiplicand register. Okay, to store the multiplicand mn. They have the multiplier register to store the multiplier mr. They have the product register to store the product p. And they have another ALU in the multiplication hardware diagram. They have another ALU. Why is that? Because they will need to add mn plus p. That is why they have used this arithmetical logical unit ALU. Okay. So do we understand why this is the hardware diagram in here? Why there are 3 registers and 1 ALU? Is it clear to all of you? Please respond.
Yes, sir.
Sir, is p value is always fixed or not?
What?
Is p value is always fixed or
Can you
not, sir?
repeat again? Why this will be?
P ভ্যালুটা
Why
সবসময়
this
কি
will be fixed?
Sir, we are using 4 zeros
P value
here.
will always be what? Yes, initially the result is 0. That is the initial step. Result should be always initially 0. Then we are going to get the correct result on the product register.
Okay, okay,
That
sir.
is initially. Initially product register is 0, mn is 8, mr is 9. So, okay, this is the hardware diagram where we have multiplicand, multiplier, and product and ALU in here. Okay, so we are going to see the algorithm in here, multiplication algorithm. Start, then whatever happens, we are going to test this algorithm in here. Okay, so now there is another thing in here, that is right shift mr one time. We have to shift right the mr one time. Why? Because check in the algorithm every time we check the 0 number bit of multiplier. But do we really want to multiply mn with 0 number bit every time? No. First time we want to multiply this mn with 0 number bit. Next first bit. So if this algorithm is multiplying the mn with 0 number bit each time, then we have to make sure this 0 number bit is in the 0 number position in the next time. To do that, we have to shift right mr every time. Okay. So if that is mr currently, for example, 1001, and we have multiplied mn with this one. Now we want to multiply mn with this 0, and we want this 0 to be in this position. So we have to shift right. Shift right means this value will go. We are going to add a 0 at the right. This is shift right. Then the 0 number bit will be this bit. In the next iteration, it will be 0 number bit. In the next, it will be 0 number bit. So this is how we are going to actually perform the multiplication. We have to shift left mn each time, shift right mr each time, and then add mn plus p to store on p if the 0 number bit of mr is 1. So this is the algorithm and this is the simulation we are going to see. Okay, so let me show you. After starting the algorithm, what we have to check? We have to check the 0 number bit of the multiplier. Now we are going to multiply 8 by 9. No, actually in here, in this example, we are going to multiply 6 with 7. So result should be 42 in here. 32 plus 8 plus 2, 10, 32 plus 10, 42 in here. So we are going to multiply 6 with 7 and we are going to follow the algorithm given in the flowchart. Okay. So what are the initial values? Remember, looking at the hardware diagram, multiplier is of 32 bits, multiplicand, ALU and product are of 64 bits. So looking at this hardware diagram, can we not say that our multiplicand and product will be the double of the size of the multiplier, right?
Yes, sir.
Okay, so we are going to say that this is our multiplier in 4 bits. Multiplicand 6 will be in 8 bits. To make it a 8-bit number, we are going to add 4 zeros at the left. And product should be 0 but in 8 bits, right? Please respond.
Yes, sir.
Okay. So in the step one, what we have to do? We have to test the 0 number bit of multiplier, 0 number bit. So if that 0 number bit is 0, we are going to do something. If that 0 number bit is 1, we are going to do something else. So can you please tell me, looking at the initial values, what is the value of the 0 number bit? Is it 1 or 0?
1, sir.
If that is 1, we are going to add mn plus p to store on product register. So mn plus p onto p. That is what we have to do. So mn plus p onto register p. This is in step 1 we have to do because the mr 0 number bit is 1. So this is mn in here. This is initial p in here. And if we add these two numbers, if we cannot add this in here with our eyes open, so we can use calculator. Okay, if we directly cannot calculate this addition, we can do it with calculator, using the calculator. Okay, so this is the product result in here, the addition. And after the addition, this is our mn and this is our mr. So what we have done in here, we have added multiplication with product and placed the result back to the product register. Now we are going to shift left the multiplication register left 1 bit, shift right the multiplier register 1 bit. So we have to shift left multiplicand, shift right multiplier one time. So we are going to shift left this mn, and how we are going to do that, you have to see that carefully. Okay. So we are going to merge this as 8 bits in here. Now we have to shift left. To shift left, we are going to add 0 at the right, 0 at the right, and we are going to remove that left-sided 0. Okay, so this is our new multiplicand after the shift left. And this was our multiplier in here, and we have to shift right that one. To shift right, we are going to add a 0 at the left. We are going to remove the right-sided 1. So this is our new multiplier. So is it clear? Please respond.
Yes, sir.
Okay, fine. So now, as we have completed the step 1, we are going to check 30-second repetition. Why? Because multiplier is assumed as 32 bits. So if multiplier is 32 bits, we need 32 steps in this algorithm to actually perform the multiplication. Let me check if the recording is going on perfectly. Okay, fine. So if the multiplier is of 32 bits, we have to repeat this process 32 times to complete the multiplication algorithm, or we have to complete 32 steps. As we can see, our multiplier is only of 4 bits. We need only 4 steps to complete the multiplication. So our first step is perfectly done. So first step is done. There is no confusion. Now we are going to go to the next step. Now in the next step, what we have to do? We have to come back again in here in algorithm and check multiplier 0 number bit. Now looking at the 0 number bit of the multiplier from the previous step, can you please tell me what we have to do? We have to come back here, right? because the zero number bit of the multiplier is 1. So we have to come back here, and in here we have to do mn plus p onto p. So this is new mn, this is new p. Now if we add these two in calculator, this will be our new product register. And if this is our new product register, then what we are going to do? We are going to actually shift left mn, because after the addition we have to shift left mn, shift right multiplier. So this was our mn and this is our mr. Now what we are going to shift left this mn one time. To do that, we are going to remove this 0 from the left, add a 0 at the right, remove this 1 from the right, add a 0 at the left. So is it clear? Please respond. Step 2.
Yes, sir.
Now, as step 2 is clear, in the step 3, we are again going to check the 0 number bit of the multiplier. Now again, what is the 0 number bit of the multiplier? After the
One,
step
sir.
2? 1. For 1, we are going to do this again. This is mn, remember. This is mn, this is new product register, and we are going to add these two to get this product. We can use calculator in case we need. And after that, what we are going to do? We are actually going to shift left this mn one time. To shift left this mn one time and shift right this mr one time. Okay. So we are going to shift left this mn. To do that, we are going to remove the left sided 0, add a 0 at the right. This is our new mn. And remove 0 from the right, add a 0 at the left to shift right this mr. This is our new mr. Step 3 is also completed. Now in the step 4, before we go to step 4, can you please tell me what is the 0 number bit of mr?
0, sir.
The 0 number bit of mr is actually 0. So we do not have to add anything in here. We have to directly go to shift left and shift right. So what we are going to do, we are only going to shift left and shift right. Shift left and shift right. And we are not going to change the product in here, as we have no addition calculation in here. So to shift left, we are going to make this 8-bit, remove the left side at 0, add a 0 at the right, remove right side at 0, add a 0 at the left. So this is our new mn, final mn mr, and the product register. This is our multiplication result. 32 plus 8 plus 2, that is 42. 6 into 7 should be 40. So this is so perfect. Let me drop this solution in the chat box. Is there any confusion in the solution? Any confusion? Any confusion? Let me know. No confusion? Fine. Okay, so I'm going to.
There will be always 4 steps, right? For 4
If
bit.
the multiplier is 4 bit.
Yes, sir.
স্যার এটা কি প্রশ্নে উল্লেখ করা থাকবে যে মাল্টিপ্লায়ার 4 বিট?
Yes, it will be there in the
আর স্যার
question.
পি কি সব সময় ওইরকম 8 বিটে নিব আমরা ইনিশিয়ালি?
P and mn will be double of the P. Yes, P and mn will be double of the size of mr. So in case mr is of 8 bits, we have to take mn and p as 16 bits, right?
ওকে স্যার। স্যার তাহলে এমআর এর সাইজটা উল্লেখ করা থাকবে যে 4 বিট অথবা 8 বিট।
Yes. Yes. Either the size of the mr is given or the number of steps are given that complete this multiplication in 4 steps. Okay. So here is that task for you in the class that all of you have to do and submit your solution in the chat box. All of you will drop all the solutions like I have given for the first one. I have given the simulation up to the final product register result. You have to drop all the results in the chat box for this multiplication only. You have to multiply 4 with 3 to find the result 12. Remember, 4 is multiplicand, 3 is multiplier. You have to find out the result. Remember, whenever, for example, if I can find that, for example, this is the result, and we got that result in the step 3, after the end of the step 3, but we still have to show the step 4. Even if we get the result in step 2 or 1, if multiplier is 4 bits, we have to show 4 steps. Otherwise, we are not going to get full marks. So wherever the result we get doesn't even matter. We have to complete 4 steps for 4-bit multiplier. Okay. So complete this multiplication. I have dropped this question in the chat box, and I am only going to share the algorithm with you, flowchart with you, so that you can actually find the solution of this algorithm using the steps. Okay, necessary steps. Do that and let me know your whole solution in the chat box. Drop your whole solution in the chat box so that I can check. So I'm waiting for your response. Take 20 minutes, 30 minutes, whatever you need to find the solution, and do let me know your solution in the chat box. I'm waiting for your response.
স্যার এখানে পি এর ভ্যালুটা কি 0 ধরবো 8টা, নাকি কোশ্চেন যে দিয়েছেন সেটা?
You will assume 0, 8 zeros.
স্যার তাহলে আপনি যে
In the
পিটা উল্লেখ
question,
করছেন
the
এখানে,
output is given. That is the
আচ্ছা স্যার
result.
ঠিক আছে, ওকে স্যার।
Okay, and Afanur Rahman, you need counseling times. You can stay after the class to get that.
ওকে স্যার।
Okay.
স্যার 2 স্টেপে তো ভ্যালু চলে আসছে, বাকি 2 স্টেপ কিভাবে করবো?
You have to
এটা করা
complete
লাগবে?
all the steps. Follow. Yes, you have to complete all the steps. Follow the algorithm. Follow the algorithm and complete all the steps. Hossein Sarkar had dropped the solution of the
सर ठीक
okay,
है
your
सर
solution is correct. Yes,
Yes, sir.
correct.
ओके सर
Okay, many of you have submitted the solutions. Abdullah Al Fahad. Abdullah Al Fahad, there is some problem in your solution. I can see there is some problem in your solution. How can MR? Okay, MR is perfect to me, but Amen is not after the step one, I guess. No, no, no. Amen is also correct. Let me check. In the step two, there is problem in the Amen. You haven't shift left the Amen. There is the problem. Okay. Even in the shift step three, four, in none of the steps you have shifted the Amen left one time. Okay, Abdullah Fahad, there is problem in your solution.
Yes, sir. Yes, sir. I got it.
Faria Jabin Disha. Step one correct. Step two correct. Three correct. Four correct. Faria Jabin Disha. Base solution is correct. Okay, fine. So should I give this as a homework for those who are yet to try, or you need time to find the solution? You are going to take time to let me know. Do you need some more time? Because I think by this time you should have found the solution. Do you need more time, or should I just take the attendance and in today's class? You guys let me know.
স্যার আপনি বললেন পি এর ভ্যালু ইনিশিয়ালি জিরো ধরতে হবে, তাহলে সিয়াম হোসেন সরকারের সলিউশন দেখলাম ওখানে স্যার পি এর ভ্যালু জিরো কেন ধরলো না?
Initially, it is mistakenly given that actually he has assumed that as 0. Let me check with. Okay, Siam Hossain Sarkar, in your solution there is some problem.
স্যার আপনি যদি একটু
Not
সলভ করে দিতেন
some.
ভালো হতো।
There are many problems in it. Why I need to give you solution of all the problems? You
স্যার
tell me.
স্যার এইটা সলভ করে দিলে আমরা মিলিয়ে নিতাম এবং আপনি এইচডব্লিউ অন্যটা দিতে পারতেন, আমি সেটা করতে পারতাম।
No, no. This is HW. If you want that solution, Faria Javan, this solution is completely perfect. Okay, you can
স্যার
check
সেও
that
তো
in case.
স্যার সে তো ইনিশিয়ালি দেখায়নি, তবে সে মনে হয় পি এর ভ্যালু
No,
জিরো
no,
ধরে
no.
নাই প্রথমে।
Everyone has to assume P as 0. Otherwise, how they are going to get any values? Right. Okay,
Sir,
let me show you. Let me show you. Initially, you have to. Yes, yes, you have. You want to say?
sir, initially P তো আপনি যেটা দিয়েছেন ওইটা নিছে, like ওইটার
No,
সাথে
no, 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 no. I didn't give that initial value. I have given that as the final value. Look at that. Let me share.
oh, okay sir, I
This is
didn't
the final value always.
okay sir.
I have given you the result in here. Why you guys are so confused? P has to be 0 in the initial stage, right?
Yes sir, I did the mistake here.
Okay, if that is 0 initially, then first multiplication of the result should be like the Mn. Let me check if that is for example, Mn and P is different again for that as well. Okay, so let me show you some steps of that multiplication. Okay, so let me copy this one here. Okay, so are you watching that word file?
No sir, only the slide.
Only the slide? Okay, okay. I'm going to show you the word file. Okay, let me share my entire screen. I thought you guys will do it easily, but a lot of you are confused actually. I've shared my entire screen. Can you see?
Yes sir.
Okay, so this is it. Now I'm just going to show you one step. I guess that will be enough for you. So this is Mn, this is Mr, and this should be our product, final product. Initially, the product should be like this, right? Please respond.
Yes sir, 0.
Okay, so Mr should be this one. What is that? Okay, so Mr should be 0011, right? And Mn should be 0100. This is the initial state, right? Please respond.
Yes, sir.
Yes, sir.
Now, after this initial state, we have to look at the zero number bit of MR. If that is one, what we have to do? We have to add P plus Mn, right? So this is Mn, this is Mn, and this is initially P is 0. So Mn should be this value, right? The P should be this value. Please respond.
Yes, sir.
Yes, sir.
This should be our P, I mean the step 1, and Mn should be this one. We have to left shift this one later after the addition. And this is our MR. Okay, fine. This is our MR. So now in the step 1, what we have to do? We have to shift left the Mn one time. Add a 0 at the right. This is our first Mn after the shift left. And we have to shift right. To do that, we are going to do this. Add a 0 at the left. This is our new MR. Is it clear to all of you? Please respond. I'm going
Yes.
to be a bit quick to let you understand. So this is it after the step 1. Now this bit is 1 again. Please
Yes,
respond.
sir.
Yes, sir.
This bit is 1 again. So what we have to do? We have to add Mn. Add Mn with product P. Now if we add this, we are going to get this value in here. Let me show you. 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, 0. So this is the new product. Is it clear to all of you? Please respond.
Yes, sir.
Now we are going to shift left Mn one time, shift right Mr one time. This is as simple as that, okay? So if we shift left Mn one time, we are going to add a 0. We are going to remove that 0, add a 0 at the right. This is our new Mn. And this is our new Mr, right? Please respond.
Yes.
Okay, now the 0 number bit is 0. So we have nothing to do like this. We have nothing to do like this. We are only going to shift left Mn, and shift right Mr. Okay, shift right Mn and product will be this. Product will not change. We are going to shift. If we shift right Mr will be this. If we shift left Mn, then this will be our new Mn. Now, as the 0 number bit is again 0, we are going to actually use this product in here, and then we are going to shift left the Mn and shift right the Mr. If we shift right the Mr will not change actually. Mr will be this, but if we shift left this one, this will be the final outcome. Is it clear to all of you? Please respond. Is there any confusion? Any confusion?
No, sir.
No, sir.
I'm going to drop this code in the chat box again. I guess there will be no more confusion. Okay, so this is so easy. In case you don't get yourself confused with what should be the P initially. Remember, initially the P should be always 0. So I have given the solution in the chat box. I guess all of you are not aware of the solution. So do practice this kind of problems at home, okay, for any numbers within the 4 bits, okay, not more than that. Okay, so we are going to end today's class by taking the attendance. If you have any question, you can ask. Otherwise, I'm just